Still on trail sheet 1. We're on question 1. We now move to B. So we've done B1. So B2 is x squared is equal to negative 6y. So similar to B1, except now it has changed the direction. So the orientation is different. So it was supposed to be. So once you're given this type of equation, you put the original form. The original form is x squared is equal to negative 4 p y. Okay, so because it's negative 4 py, then you know that 4p is equal to 6. So that p is equal to 6 over 4, which is equal to 3 over 2. Then we know the directrix here is the directrix is the line y is equal to p when it is negative. So the line is going to be 3 over 2. So the focus point is going to be 0, negative p, which is 0, negative 3 over 2. Then you can have the sketch. Say, okay, then the sketch is going to be the origin is a vertex. And then here we get negative 3 over 2. And then we'll have a line positive 3 over 2 as our directrix. Excuse. So that's how we come up with our sketch. We change the orientation, like the third one. Y squared is equal to 8x. So you know it has now gone to the x-axis. So it was supposed to be y squared is equal to 4 px. This means that 4p is equal to 8. So p is equal to 2. And then from my equations, the standard form, the directrix is supposed to be, we can start the focus. The focus is supposed to be p, 0. So it will be 2, 0. So the directrix will be the equation x is equal to negative p. So that x is equal to negative 2. Then you have the sketch. So it's facing where? The right. P, now it is known, so it's 2. That's 2, 0. And then you have the line, negative 2. So what we've been calling the latus rectum, if you ask to find the latus rectum here, it's this guy here, the distance of this line. And there's a formula I said it's what? It's 4p. So if you're asked to find the latus rectum, so you just say 4p. And what is p? P is 2. So it will be 8. That's the distance there. So to give you an idea to say, okay, so because it's 8, so this point here is supposed to be 4, and this point here is supposed to be -4. That's the one where this distance here is going to be 8. Okay. So we can now extend our discussion. We move to the ellipse. Okay, there's a question from Oscar.
Yes, I have a question, but see, so in Parabola, I can give you the question you try to solve, because the somehow it's, yeah.
Okay.
Yeah, yes, the question is saying a conic section centered at -1, -2. Now, I mean -1, -1 as one vertex at -3, -1. The distance between the directrix and the vertex is 3e/8, where e is its eccentricity. Given that e is a multiple of 2, find the value of eccentricity and 2, the equation of the conic section.
Okay, so because e is a multiple of 2, so e is non-zero. So it being a multiple of 2, and also e is non-negative. Okay, e is never less than 0. So e being a multiple of 2, it means that it's either e is 2, 4, 6, 8, going up. So if e is equal to 1, then it's a parabola. If e is less than 1, then it's an ellipse. If e is greater than 1, then it's a hyperbola. So when we touch the hyperbola, then we'll answer this question. Just keep it. So we learn the basics like the one for the parabola. Then we also learn for an ellipse. Then for the hyperbola, then I'll be able to sketch and answer any question coming from each part. Okay. So you go to an ellipse. So an ellipse, a few things that we need to know. For the one centered, the standard form of an ellipse centered at the origin. So you say the center will be 0, 0 for which type? If we have x squared over a squared plus y squared over b squared is equal to 1. So this is one form. So if you have this form, I say, okay, if a is greater than b, then the axis is the x-axis, which is the line y is equal to 0, 1. But if it's sitting like this, it's either to sit like this, or you have x squared over b squared plus y squared over a squared is equal to 1. Again, a greater than 0. I mean a greater than b. Then the axis is the x-axis, which is the line. I mean, this one is the y-axis, the major axis. The y-axis, which is the line x is equal to 0, like that. Then we'll have the vertex. The vertex, the first one is the major, the major vertices. So here now we have 2 of them because of the shape of an ellipse. So we'll have a comma 0 for the first type. We'll also have negative a comma 0. If it's the other one, we'll have 0 comma a. We also have 0 comma negative a. Then the foci, because there are 2. We just put the major one, so you can also put the minor one. The minor vertices, we'll have a b comma 0. The b should be on the y, so 0 comma b or 0 comma negative b. And then same thing here. Now it will be b comma 0 and negative b comma 0. That's for the minor. Then you go for the foci. For the foci is coming for this type. You introduce a c that you can find by calculation. So you say the foci is going to be a negative c comma 0 and positive c comma 0, where c squared is equal to a squared minus b squared. So c specifically is the root of a squared minus b squared. So at the other one, then c will be on the right, and 0 comma negative c, where c is found in the same way for this one. And then the length of the lattice rectum for this case is 2b squared over a. Then the eccentricity is given by c over a, and as you can see, c is this one, so you can also write this as a squared minus b squared over a. You can also do this. This can also be written as the square root of a squared over a squared minus b squared over a squared, which can be simplified as the root of 1 minus b squared over a squared. So what we've done is that we've squared a. Now you know that if a is the same as a squared root, so you can square the a down and then give it a root. Then if I have a over b in the root, it's the same as having root a over root b. So I've moved from the right to the left to put them like this. So these formulas that we are putting here, they'll be useful in application questions. So that's why they are necessary also to be discussed.
I'm a bit confused there.
C over A is equals to the square root of A squared minus B squared over A. Where is that coming from?
C over A is equal to the square root of A squared minus B squared over A. Since we are saying C is equal to the root of A squared minus B squared, then where there is C, we can put this. So you can also find eccentricity in this one.
All right, sir. Thank you.
Okay. So these formulas are down. They work for both parts. Then what else is important on the ellipse? On the ellipse. Okay, for this type, maybe something else will come in. First, we look at also when the center is not at the origin. How do we come out of that situation? So we put B, and the center is not at the origin. So there we have part A. Now this is when you have x minus h squared over a squared plus y minus k squared over b squared is equal to 1. And a condition that a is greater than b, then what will follow? We'll have 1, the length of the major axis is 2a. So you see the shapes, and then where we're saying 2a, and then the other one, then you can have the coordinates. The coordinates of the vertices to be h plus or minus a comma k, comma k, and then you have the length, of minor axis. This one uses b, and then the coordinates, of the covexes, that is on the minor, that will be h at k plus or minus b, and then the most important ones, the foci. These will be given by h plus or minus c comma k, where c squared is still a squared minus b squared. Then for b, if we have x minus h squared over b squared plus y minus k squared over a squared is equal to 1. And then again, if a is greater than b, then we're saying here the length of the major axis is still 2a, and then the vectors for the major, now this time you get h comma k plus or minus a, because it has gone on the y, and then the length of minor axis is still 2b. Then the co-vectors, this time around it will be h plus or minus b, comma k fixed. So what was important to get the foci? The foci which is in now h, comma k plus or minus c. Still c squared is still a squared minus b squared. So these shapes that we're talking about here are the shapes that looks like this one. On the x-axis, it will be a shape of this nature. Okay, so this can be centered not necessarily at the x-axis, not necessarily at the origin. Suppose this is the center, h comma k. Then we will have the foci here, the foci here. In this case, so say h plus a, I mean h plus c, and then h minus c, and then the end points, which we call the vectors. Now here we have h plus a, and here we have h minus a. Then this line cutting here, this line cutting here is the one which has the coordinates that are being talked about as the co-vectors, which will be k plus b and k minus b. Now these are points away from the y-axis, so we'll put their coordinates on the left, like this. So if this k is not 0, you can also be putting k's here. Can be putting k's here. If this k is not 0, you can be putting k's here. So we'll have k and we'll have k like this. Then the other one will face on the y. There's something that we also need to note. Is it? Okay, the eccentricity we've talked about. Let us take them we've discussed. The directrix of the, okay, that's the last thing that I was looking for. The ellipse also have the directrix, whose formula is x is equal to a over e. And because we have two foci, so we're going to have two directrices. So x is equal to a over e, and x is equal to negative a over e. Now remember, e is calculated in which way? So e is calculated as c over a. So when we have a over e, you can write this as x is equal to a over, we'll say that e is c over a, so you can write c over a, but this is the same as a squared over c. Remember what c is? C is also written as the square root of what? Of a squared minus b squared. So all these may be needed somewhere. That's why you need to know them, so that when an application question comes, you know the formula. So if they're talking about eccentricity, then you know which formula have the eccentricity, and then what are you given. If they give you the directrix, then they say something about E. If you have the formula for directrix, it will be easy for you to apply it. So let's see a question from the theory sheet that are based on the ellipse. Like C from 1. Find the foci vertices and then sketch. 1 x squared over 4 plus y squared over 9 is equal to 1. So which form are we in? We're in this form, where the diameter for y squared is bigger than the diameter for x squared. So we know that the axis here is the y-axis. With a squared being 4, so this means that a is 2. With b squared being 9, this means that b is 3. And then c squared is a squared. So I've switched them.
Sorry, just a minute. Okay.
So we're saying a squared is equal to 9, the bigger one, so a is 3. And then b squared is 4, so b is 2. Then c squared is equal to a squared minus b squared. This is going to be 9 minus 4, which is equal to 5. So c itself is the root of 5. Then we can now sketch because we have everything.
Sir,
Hello.
that's a question where I'm getting confused.
Mm-hmm.
Where we are doing a 9 minus 4, why are we not powering them? Where we say 9 times 9, we just subtract that like that. I'm getting confused.
Because the formula is in this form. So the one we are dealing with now has switched these two. So it's in the form. So these, they are already squared. So when you say a squared, then you pick what is sitting at that position. So it is 9. So a squared is 9. When you say b squared, then you go and get the number that is down there. So it's 4. So they have already been squared. That's why when you look for the actual a, you square root. So that when it is just c squared requires that you get them the same way they are. So you just say, oh, I have 9 minus 4. Then it is 5. So no need of squaring them. They are already squared.
Oh, I get the point now.
Yes. Then, so he said this is on the y-axis. So our vertices on the y, remember centered at the origin, our vertices on the y will have negative a and positive a. And then our vertices on the x will have a negative b and positive b. So we have this structure here to be sketched. Like this. Then the origin is 0, 0. Then the foci. Now interested in the foci. C. So C, that's root 5. And negative root 5. So if the question says, what's the directrix for this? say that the directrix here is what? X is equal to A over E, which is the same as X is equal to A squared over C. So say X is equal to A squared over C. Now A squared is 9 over C, which is root 5. So root 5 is smaller than 3. So you get 3 point something. So if you had to sketch this directrix, the positive one, it has to be up here. So if I do this, so the positive one, so it has to be somewhere here. It has to be somewhere here. So in this case, it's not calculated as X, so it has to be calculated as Y, because the foci has gone on the Y. So it won't come here as X, it will come here as Y. So you put it up there and also down. Remember, we have plus or minus. The other one will be down here.
Excuse me, sir.
Hello.
What are we trying to find is that A squared over C.
So you're finding the directrix. So for the directrix. So just saying, in case the question is extended to where they want you to find the directrices also. So you should keep in mind that it's the same as Y is equal to A squared over C. This is plus or minus. So the plus one goes up, the minus one goes down. Though mostly when it is sketching, they won't ask us to sketch the directrix, but then they will ask us in the application. So you see questions like, given the directrix and the eccentricity, find the equation. Because they know that in these formulas, you have A, you have B, you have C. And if you have A, you have B, you have C, then you easily get H, you get K, the centers, then you have the equation. Or they can give you the center and then hide some other information. They just give you the eccentricity, where they know that you're going to get A and B from there. Okay, maybe do one question which has an extension, where like this one, which is X minus 4 squared over 16 plus Y minus 3 squared over 9 is equal to 1. Now we have the center, not at the origin. So our center H comma K, in this case, 4,3. So it's the center. Then from the center, we get A squared is equal to 16, implying that A is 4. B squared is equal to 9, implying that B is equal to 3. So C squared is 16 minus 9, which is 7. So C is the root of 7. So what do you want to get? We now want to get the vertices. For the major, and remember, the vertices are going to be H plus or minus A, comma K. So in this case, we'll have the first one. Our H is 4 plus, so let me say plus A, our A is 4 also, comma K, which is the 3. So this will be 8,3. Then the other one, will have 4 minus 4,3. This will be 0,3. The major vertices, the minor ones, which are the core vertices. So if I have a formula, very easy. So it is H, K plus or minus B, but we have our h. Our h is 4. Our k is 3 plus b is 3. So this will give us 4,6. Then the other one, 4,3 minus 3. So this will give us 4,0. Is it? K is 3, B is 3. Yes. So we get 4,0. And then we need the focus. So the foci, which is given as H plus or minus C, comma K. But we have H. We have H. H is 4 plus C, the root of 7, comma 3. We also have that H is 4 minus the root of 7, comma 3. So you can sketch this graph. Okay. Then how does it go? So let's put the points. So the points 0. This is 8,3 as the vertex. So 8,3 somewhere here, and then 0,3 here, and then the center the 4,3 here. So have an ellipse of this nature touching at 0. So it's touching here, we're starting. Then we have the foci here, 13, 4 plus root 7, 4 minus root 7, and the center is 4, and this is 3. So unfortunately, this will be cutting us soon, but this one is all sketched. It has all the properties here. So this is where today's class will end. We've talked about the parabola and the ellipse. So in the next one, we'll talk about the hyperbola, and then I'll answer all the questions on the hyperbola and ellipse, because the other parts like the eccentricity, those are very minor things. So meaning that we'll be able to finish now the whole tutorial sheet, because we have everything that is needed there. What is key is